There we go. All right, so let's look at question number 2 from the 2021 AB exam, and I'm solving this in real time. I've not read it yet. So we have a particle motion problem moving along the x-axis. They give you the velocity. It's something ugly, so I'm going to go on in my calculator. I'm going to clear out my work for question number 1, and let's store this. So the sine of x to the 1.5 power, that's pretty clean. That's an ugly graph. Let's see, at time 0, the particle P is at position 5. So we do have an initial condition. So I'm going to write that down. So question number 2, at time 0, particle P. And this fact they're mentioning particle P makes me think they will eventually introduce a second particle, maybe called Q. So we know the initial position of P. Oh, it's right here in the next sentence. The second particle, Q, also moves along the x-axis, and the velocity of Q is given by that. So I'm going to make a few notes to myself. I stored the velocity of P for F1 of x. I'm about to store the velocity of Q for F2. And so velocity of Q is that function. So let's go over here. Velocity Q. Bye. See y'all later. Velocity Q is what? X minus 1.8 times 1.25 to the x power. And I'm going to go ahead and adjust my window because they are telling us that we're interested on the interval 0 to pi. So let me fix that. I'm not going to adjust my y's. And they give you an initial position for Q. At time 0, Q is at position 10. So the particle Q at time 0 is at a position of 10. Find the positions of P and Q at time 1. Easy peasy. I like these questions. We have an initial condition. We have their velocities. We need a position at a later point in time. So the position of particle P at time 1 is the initial position of particle P plus, and then we'll measure the change from P from 0 to 1 of Vp of x. I think I'll use T. Vp of T. dt, I'll throw that in the calculator, and similarly, my position of particle Q at time 1 will be the initial position of particle Q at time 0 plus the change from 0 to 1. We'll use the velocity of particle Q for this one, and we will slap both of these in the calculator and get an answer. So over here, 5 plus the integral 0 to 1 of f1 of x dx, and this will be my position of particle P, is 5.2667. And then for Q, same thing, except it's 10 plus, and we'll use F2 instead of F1. F2 of x dx, get that decimal answer. 8.564. So there are your positions of P and Q. Very predictable. Nice questions. 8.564. I think I remembered that correctly. So on to part B. Are particles P and Q moving towards each other or away from each other at time 1? Okay, so are they moving towards each other or away from each other? Right now, we know where they are in relation to each other. So my game plan is to find out now which direction they're traveling. Right now, we know that P, particle P, is at 5.267. We know that particle Q is at a position of 8.564, and this is when T is equal to 1. Okay, I had a brief interruption there. So we know where P and Q are. I need to find out what direction they are moving, and to find the direction of travel, we're going to find the velocity of P at time 1, and then we will find the velocity of Q at time 1, and those will be computed in the calculator. Now remember, the velocity functions are what was provided. So, my velocity of P is F1 of 1. And F2 of 1 is my velocity of Q. And we got 0.841, which is greater than 0. That means P is moving to the right. Velocity of Q was -1. That is less than 0. That means Q is moving to the left. Therefore, they are moving towards each other. And I do like to be a little bit detailed in my explanation. And so, geez, I don't want to write a paragraph. Okay, so x at time t equals 1, p is at an x coordinate of 5.267 and moving right because the velocity of particle p at time 1 was positive. Q is at x equals 8.564 and moving left because the velocity of particle q at time 1 was negative. Therefore, they are moving towards each other. Kind of went a little bit wordy on that one, but there we go. All right, so number C, find the acceleration of q at time 1. Is the speed increasing or decreasing? Holy cow, that is easy. I like these questions. So far, despite the wordiness, these questions for number 2 are fairly predictable. They're fairly nice. Hopefully you felt the same way if you took the AP exam. So for part C, the acceleration of q at time 1 we'll do in the calculator with the derivative at a point command. And so menu, calculus, derivative at a point. I'm going to plug in 1 to the first derivative of f2 of x. Hit Control Enter, and we get 1.0268. 1.0268. That is a positive value. In part B, we found out that the velocity was negative at 1. So Q's speed, forgot the S in speed, is decreasing at t equals 1 because the velocity of q at time 1 and the acceleration of q at time 1 have opposite signs. Same signs, speed increases. Opposite signs, speed decreases. And then number D, find the total distance traveled by P over the interval. Holy cow, these are all just memorized formulas and approaches. This is a nice question. Total distance in the world of AB, total distance is the integral from point A to point B of the absolute value of your velocity, and we are wanting particle P. Another one, we'll just throw this straight in the calculator, like it. So Shift plus. We're going from 0 to pi. Don't accidentally do 1. We've been focusing on 1 so much. Open up my absolute value, f1 of x, bx, Control Enter, and we get a total distance of 1.705. And I'm pretty sure they did not provide specific units because we are traveling along the x-axis. But I'm going to look again and just make sure they did not. And I don't see any units provided. So we are good for number 2.